Hello and welcome to my technical presentation of class project phase 4 of the Sun Devil Connect project. Heading into it, we will start with the problem and motivation. The first thing we found is that there was no central discovery for students to have a unified platform to browse and join campus clubs. Information was scattered across emails, flyers, and separate sites. Um, Next thing is that there was no manual club management. Club leaders managed memberships, events, announcements through spreadsheets and other group chats and other forms that had no structured workflow. And another thing was that there's no other way for admins or university administrators to approve new clubs, monitor club activity, and handle reported content. Um, we wanted to create a centralized platform that everyone can use all in one place to, see events and be able to browse what's going on campus in real time. Um, Heading into the system architecture, we use a standard two-tier architecture with the REST API. The client or front end uses a React and V app. This is what the user will see and interact with. It refreshes whenever they interact with the page, which is mainly why we wanted to use React because it's very user friendly and very easy for us to implement and something we were familiar with. For the backend or the server side, we use Node.js and Express, another JavaScript framework that we were comfortable using, and then we also use more REST APIs there for authentication and role-based controllers, and also for to authenticate users when they log in. And for the database, we use SQLite. It was very easy and friendly to work with. We used 8 tables, and we created this on the start. And the main reason why we wanted to do that was because it really needed no configuration to set it up. And here's our tech stack. More information of the tech stack that we used. Like I said, front end, we used React 18, component-based UI with hooks, and it's widely known by us. V has zero config proxy to Express backend, which makes it very easy to deploy. And we also use React Router, which is a library used in React to declare the routes for protected row enforcement. That way, users are unable to enter pages that they're unauthorized to access. The backend, we use Node.js and Express 5, which is the lightweight REST API and async friendly with minimal boilerplate. And the database use SQLite, needed zero install and it's file based. It's perfect for us to make these demonstrations without making such a big file and setting everything up on our local. That way, whenever someone else wants to test it, they're able to easily, create their own file and their own database. And then for authorization, use JWT and Bicrypt JS. It's a stateless token authorization, and it also handles password hashing for users. Next, we get into the database schema. We use 8 tables. Um, Users, they have the fields for ID, first name, last name, email, passwords, and role. And then another thing I'm getting to is the clubs as well. The clubs have ID, name, description, category, mission status, and advisor ID. These are kind of like our main 2 tables that we want to use to identify different users in the system and clubs that we have. Club memberships are a way to connect users to clubs and also to find out who is a leader and who is just, a regular member. Uh, Another thing we made was for the events. We made a table for events so people are able to enter the information for, their ID, the club ID that the system will find to identify the different events we have, the name, description, location, date, time, category, and price that other users are able to see. We also have event registrations to display to users how many people have signed up for events and who did. And then we have posts that club leaders are able to make on their club pages. Users are able to see who made the post, what's in it, and the time it's created at. Um, and then we also have procurement requests. This is kind of like how people would kind of want to ask for a club or pledge for a new club to be created, and that has to be approved or rejected by the club admin or the admin of the website. And then we have flag reports. This is how Users will be able to report content that they don't think should be on the site or is not user friendly for other people to see. It's a very important thing to manage content on the site, especially for a university. We don't want offensive material to be on there. And then the next thing we'll go into is authentication and security. It works in 4 steps. On register, the password is hash with bcrypt at cost factor 10. The raw password never touches the database, so even developers would not know the user's password, protecting user privacy. On login, the bcrypt compares the hash, and then it issues a 24-hour JWT container containing the user's ID, email, and role. And from there, the client stores that token in local storage and attaches it as a bearer header on every request. That's how the system will know that the user has authentication and who it is. And on the back end, we authenticate the middleware. Um, that is where the token is verified and injects a decoded user into a request.user, making the role available to every controller. And then finally, the role table on the right shows what each role can actually do. These are like, their functions and core functions that they should be able to do. The students should be able to browse clubs, join and register for clubs. Club leaders should be able to create clubs and other events and manage posts and other members. Advisors should be able to approve and reject procurement requests. And then admins should be able to have full oversight of the website, approve clubs, maybe even delete users in the future, and also go over flag content. And then the next thing I'm getting to is the API design that we chose for this project. The API has 6 resource groups. Authorization is public for register, login, and logout. Everything else is protected by the authentication middleware. Clubs have the most complexity for listing, petitioning, approving, joining, and member management. That is where we have most of our issues in. Events includes a left join to attach attendee count and a single query. And the procurement lets leaders submit funding requests for advisor review. And flags let any user report for admin review. User supports profile reads and updates. Next, we'll get into our key feature implementation. 3 features require non-trivial decisions. First, the club petition flow. When a user submits a club, we immediately insert a club membership row, making them an approved leader. And next, we have the event discovery. It gets attendee count on the server side, and the front end it handles filtering across text category, price, date, and popularity using use memo. And then third was the role-based access control, which we use JWT payload, which carries the role with middleware injecting it, and every controller we have will check for it, verifying the user role throughout the system. And then the front end protected route redirects wrong role users to a page that they have authorization to, or it will just display you're not authorized to view this. And then here is our front end architecture. We have a total of 10 pages, 4 components, an authorization layer, and API wrappers. The main reason behind these decisions is because we use React context and local storage. It rehydrates on page refresh without a server round trip. For HTTP calls, we use a single API fetch helper, which auto attaches the JWT token and throws away any unauthorized responses. And then we use route guard, which was provided by React Router. Protected route wraps each route, and then it will also redirect users to a page that they are authorized to see if they were to access a page they're not authorized. And then finally going to the challenges, we faced into 4 major bugs in development. Ran into problems with the controller imports, mainly because we use a lot of boilerplate with the logout feature. Sometimes when the user logged out, it wouldn't save on another page. So if a user were to log in another tab, for example, they will still be logged in. That was a security issue that we faced. We also had stale server processes. Sometimes the server would just outright stop during development. This was an issue with the events that we had. It wasn't properly updating, and it causes issues. And we also had missing routes. The lesson we learned from all these is that we have to manually test every single route before writing more code. Because of the moment that we assumed that the code was working, especially like when we're making a video, uh, it would bring errors that we had to address, further delaying our productivity.